first problem, tangent of beta, find the tangent of beta, cosecant of beta, if the secant of beta is equal to 3/2, and tangent of beta is less than 0. So, yesterday, when we did this one, we found this by essentially creating a right triangle and kind of decomposing from there. But I want to show you how to do this by just using the identities. And that's really all you need to actually do. So, first things first. You always want to start with your given information. And the given information is right here. This is going to tell you where the angle is and what some of the values associated with that angle is. So, first off, I would always start with the tangent, or basically this is saying the tangent is negative. So that's going to tell us, all right, if you look at the unit circle right here, and you look at, if you have a unit circle that has the negative values printed on there, this is a really good one to have. Look for the negative tangent. That's quadrant 2, and all the way down here, quadrant 3. Actually, no, it's quadrant 2 and it's quadrant 4. So it's going to be up here, or it's going to be down here. So quadrant 2 or quadrant 4. So that's going to be your first piece of information that says, all right, well, I think that it's got to be, well, I don't think that it has to be in quadrant 2 or 4. It has to be in quadrant 2 or 4. So now, after we use that first thing, I'm going to use the second part right here. The secant of beta is equal to 3/2. And this is going to basically narrow it down from quadrant 2 or 4. And so the secant, the nice thing about the secant is I know that the secant is equal to 1 over the cosine. So if the tangent is sine over cosine, and I know it has to be negative, and the secant is positive, so that tells me that if the secant is positive, the cosine has to be positive. So if the cosine is positive, sine has to be negative. So now, the sine is negative. The only place that it will be where the sine is negative and the tangent is negative is here in quadrant 4. So I know my angle has to be in quadrant 4. That's helpful because that'll tell us that, all right, this has to be negative because cosecant is 1 over the sine. So now that I know the sine is negative, I know the cosecant is going to be negative. And I also know that the tangent has to be negative. So that's why we do it. So we know which cosecant we're going to use because we're going to have to probably do some square roots. And I'll show you how we're going to do that in a second. So we're going to use Pythagorean identities. So knowing that the secant of beta is equal to 3 over 2, I need to relate the secant to the tangent, or the cosecant. So look for identities that do this. So the secant has to tie into, or relate to the tangent or the cosecant. So look at your Pythagorean identities, which are right here. That's a sine and a cosine, a tangent and the secant. That's good, because that's what we want. And a cotangent and a cosecant. Well, you know what? I want to use tangent squared plus 1 equals secant squared, because that will tie the secant directly to the tangent. So tangent squared of beta plus 1 equals secant squared of beta. What I know is that the secant of beta is equal to 3 halves. So I'm just going to sub that in. Tangent squared beta plus 1 is equal to 3 halves squared. So solve this. Tangent squared beta plus 1 is equal to, 3 squared is 9 fourths. Let's subtract the 1 from both sides. So the tangent squared beta is 9 over 4 minus 1 is equal to 4 over 4. Since it has a denominator of 4, so I'm going to subtract 4 over 4 from this. So tangent squared beta equals 9 minus 4 is 5 over 4. Now, in order to solve this, I need to take the square root of the tangent squared beta. That's going to equal to the square root of 5 over 4. Actually, it's going to be equal to the positive negative square root of pi over 4. Because I don't know which one I have, the positive or the negative one. So the tangent of beta is equal to positive negative square root of 5 over 2. And just really quickly, how you would simplify the square root of 5 over 4, square root of 5 over the square root of 4, square root of 4 is 2. But I don't want the positive. I don't care about the positive one. I want the negative one only. So I know the tangent of beta has to be equal to negative square root of 5 over 2. So that gets me a tangent. And that is the tangent that we found together creating the triangle. So you can get there just by using the identities, which are the algebra, in this. So now, from here, I got to find the cosecant of beta. So in order to do that, I need to basically focus on the secant of beta. That's equal to 3 over 2. Well, now, to get to where we need to go with this, the secant of beta is equal to 1 over the cosine of beta. So that's equal to 3 over 2. Well, now I don't need that secant anymore, so I can just ignore that. But the reciprocal of the cosine is 3 over 2, so if I take the reciprocal of both sides, the cosine of beta is going to be equal to 2/3. But that's not what I want. What I want is a secant, or I want the cosecant. So here's how you get from cosine to cosecant. So if you have the cosine of beta, and that's equal to 2/3, what I'm going to use is cosine squared beta plus sine squared beta is equal to 1. This is your Pythagorean identity that relates the sine and the cosine together. Now, the reason why I want to do this is the cosecant is equal to 1 over sine of beta. So if I can go from cosine, basically here's the path. I want to get the secant to the cosine to the sine, and then the sine to the cosecant. To get from secant to cosine, use a reciprocal. To get from cosine to sine, you're going to use sine squared plus cosine squared is equal to 1. And here, we're going to use another reciprocal. So, I did the reciprocal to get the cosine. Now I'm going to use the Pythagorean identity, cosine squared plus sine squared equals 1. So I'm going to get 2/3 squared plus sine squared beta is equal to 1. So that's going to be 4 over 9. plus the sine squared of beta is equal to 1. Subtract 4/9 from both sides. So I know sine squared of beta is equal to 9 over 9 minus 4 over 9, because 1 is equal to 9 over 9. So sine squared beta is equal to 5/9. You take the square root of sine squared beta, and that's going to be equal to positive and negative square root of 5 over 9. So sine beta is going to be, in this case, that's square root of 5 over the square root of 9, which is square root of 5 over 3. And I know that sine has to be negative, because at the beginning we were doing all that negative talk. So it's negative square root of 5 over 3. So the cosecant is equal to 1 over the sine, which is, I need to take the reciprocal, which is going to be 3 over the square root of 5. And now, from there, what we have to do is rationalize, because we can't have a square root in the denominator. So we're going to get negative 3 radical 5 over 5. And there's your cosecant. So it's a little bit more involved, but honestly, you need to also know how to use identities to solve these, because sometimes they're easier to do. So that's our first one.